A system is whatever portion of the universe chosen to be analyzed. External forces are forces caused by any external agent or agents outside of the system. For example, applied force, normal force, tension force, friction force, and air resistance force. Internal forces are forces exchanged by the objects within the system. For instance, gravity forces, magnetic force, and electrical force. An elastic collision is a collision in which both momentum and kinetic energy are conserved. An inelastic collision is a collision in which only momentum is conserved. Isolated system, a system that has no net force external acting on it. Law of conservation of momentum. It states that the total linear momentum of an isolated system remains constant or is conserved. Sigma pi equals sigma pf m1v1i plus m2v2i equals m1v1f plus m2v2f, where m1v1i plus m2v2i represents the total momentum of particles A and B before collision, and m1v1f plus m2v2f represents the total momentum of particles after collision. This means that total momentum before collision equals total momentum after collision. Delta P before equals delta P after. Example. Object A 100 kilograms is at rest. Another object B 0.4 kilograms moves towards object A at a speed of 25 meters per second. They collide. Object B continues moving in the same direction at a speed of 20 meters per second. What is the speed of A after the collision? Take towards object A as plus. Mass 1 equals 100 kilograms. Initial velocity of mass 1 is 0 meters per second at rest. Mass 2 equals 0.4 kilograms. Initial velocity of mass 2 is plus 25 meters per second. Final velocity of mass 1 is unknown, and final velocity of mass 2 is plus 20 meters per second. Sigma pi equals sigma pf. Mass 1 times initial velocity of mass 1 plus mass 2 times initial velocity of mass 2 equals mass 1 times final velocity of mass 1 plus mass 2 times final velocity of mass 2. 100 times 0 plus 0.4 times plus 25 equals 100 times final velocity of mass 1 plus 0.4 times plus 20. Final velocity of mass 1 equals plus 0.02 meters per second, which equals 0.02 meters per second towards object A. Example. A trolley A of mass 1 kilogram moves westwards with a speed of 2 meters per second. It collides head-on with another trolley B with a mass of 1.5 kilograms moving at a speed of 1.5 meters per second eastwards. If trolley A rebounds at 2.05 meters per second, calculate the final velocity of trolley B. Solution. Take towards west as plus. Mass 1 equals 1 kilogram. Initial velocity of mass 1 is 2 meters per second. Mass 2 equals 1.5 kilograms. Initial velocity of mass 2 is minus 1.5 meters per second. Final velocity of mass 1 is 2.05 meters per second. Final velocity of mass 2 is unknown. Sigma pi equals sigma pf. Mass 1 times initial velocity of mass 1 plus mass 2 times initial velocity of mass 2 equals mass 1 times final velocity of mass 1 plus mass 2 times final velocity of mass 2. 1 times 2 plus 1.5 times minus 1.5 equals 1 times minus 2.05 plus 1.5 times final velocity of mass 2. Final velocity of mass 2 equals 1.2 meters per second, which equals 1.2 meters per second west. Classwork. A bullet of mass 40 grams traveling in a straight horizontal line to the right at 400 meters per second strikes a stationary wooden block of mass 3 kilograms resting on a smooth horizontal surface. The bullet goes through the block and comes out on the other side at 100 meters per second. Calculate the speed of the block after the bullet has come out the other side. Solution. Take towards right as plus. M1 equals 0.04 kilograms. V1 initial equals 400 meters per second. M2 equals 3 kilograms. V2 initial equals 0 meters per second. V1 final equals 100 meters per second. V2 final equals what? Sigma P initial equals sigma P final. M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. 0.04 times 400 plus 3 times 0 equals 0.04 times 100 plus 3 times V2 final. v2 final equals 4 meters per second equals 1.2 meters per second to the right. Elastic and inelastic collisions. Kinetic energy due to motion. Equals 1/2 mv squared. Units joules J. Elastic collision. A collision where kinetic energy is conserved. The total kinetic energy before the collision is equal to the total kinetic energy after the collision. Inelastic collision. A collision where kinetic energy is not conserved. The total kinetic energy before is not equal to the total kinetic energy after. To determine whether a collision is elastic or inelastic, equals 1/2 mv squared is used to calculate the total kinetic energy before and after the collision. Momentum is always conserved in a collision in an isolated system, but kinetic energy is not usually conserved. In a collision, the lost kinetic energy is transformed into heat and sound. Examples. 1. A ball with a mass of 1 kilogram is moving eastward with a speed of 2 meters per second. It collides head-on with a second ball. The second ball has a mass of 1.5 kilograms and is moving with a speed of 1.5 meters per second in the opposite direction. After the collision, the first ball bounces back with a velocity of 2.05 meters per second, and the second ball bounces back at 1.2 meters per second. Let's start with a couple of questions. First, calculate the total kinetic energy before the collision, and second, calculate the kinetic energy after the collision. Alright, now for the solution. For part A, the total kinetic energy before the collision is given by 1/2 times m 1 times v1 initial squared plus 1/2 times m2 times v2 initial squared. This equals 1/2 times 1 times 2 squared plus 1/2 times 1.5 times 1.5 squared, which comes out to be 3.69 joules. For part B, the total kinetic energy after the collision is given by 1/2 times m1 times v1 final squared, plus 1/2 times m2 times v2 final squared. This equals 1/2 times 1 times 2.05 squared, plus 1/2 times 1.5 times 1.2 squared, which equals 3.18 joules. Now let's move on to some classwork. Here's the scenario. During rush hour in Johannesburg, Vehicle A with a mass of 2,000 kilograms was stopped as the traffic light turned red. Vehicle B, with a mass of 2,400 kilograms, was speeding behind Vehicle A and was unable to stop, crashing into the back of Vehicle A at 12 meters per second. Vehicle A was pushed into the intersection, and Vehicle B slowed down to 5 meters per second. Assume that momentum was conserved and calculate the speed of A immediately after the collision. Determine by calculation whether this was an elastic or inelastic collision. Homework. A bullet of mass 2 grams is fired horizontally into a stationary wooden block of mass 1 kilogram. The bullet strikes the wooden block at a velocity of 490 meters per second. The impact causes the block bullet system to slide a distance of 20 centimeters before coming to rest. Name and state the law that can be used to calculate the velocity of the bullet block system after collision. Calculate the velocity of the block bullet system immediately after collision. Is this collision elastic or inelastic? Alright, let's dive into the solutions. 1. A delta P before equals delta P after. M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. 2000 times 0 plus 2400 times 12 equals 2000 V1 final plus 2400 times 5. V1 final equals 8.4 meters per second. Part B. Ek before equals 1/2 times 2000 times 0 squared plus 1/2 times 2400 times 12 squared, which equals 1.73 times 10 to the power of 5 joules. Ek after equals 1/2 times 2000 times 8.4 squared plus 1/2 times 2400 times 5 squared, which equals 1.01 times 10 to the power of 5 joules. The collision is inelastic since Ek before is not equal to Ek after. 2a. The law of conservation of momentum. The total linear momentum of an isolated system is constant in both magnitude and direction. Part B. Delta P before equals delta P after. M1V1 initial plus M2V2 initial equals the sum of M1 and M2 times V final. 0.02 times 490 plus 1 times 0 equals 1.02 times V final. So V final equals 0.97 meters per second. Part C. Ec before equals 1/2 times 0.02 times 490 squared plus 1/2 times 1 times 0 squared, which equals 2,401 joules. Ec after equals 1/2 times 1.02 times 0.97 squared, which equals 0.48 joules. The collision is inelastic since ec before is not equal to ec after.